guys, this is Rob again with Next Gen Rider. Today I want to do a video that's going to be kind of a deep dive on the AlienRider LiDAR safety feature. Alright, so this gets delivered in the M2 Pro kit. Actually, you can add it to any AlienRider system. It's offered as a standalone product also if you want to add it to your M2 Pro system that maybe it's just cameras only or something. But LiDAR safety. So this is, as far as I know, the only system or aftermarket writing system that includes LiDAR technology. So the competitor in this space, they have blind spot detection and rear collision detection, but they're using vision or camera technology. Actually, they're using the same camera as AlienRider uses for their dash cam system. These are Sony IMX307 cameras. The competitor uses it as well, or Sony IMX307 CMOS image sensors. And AlienRider configures theirs with a 120-degree lens for dash cam recording. And I think the competitor uses a 137-degree lens, which makes sense to have a wider field of view because they're also using that camera for safety sensing. So we'll go back to the AlienRider sensor real quick and kind of talk about installation. This is how it's configured. It comes with the GoPro style mount with the 3M adhesive backing, and then a couple of holes if you want to do a fixed mounting. And then also this will accommodate an under mount or top mount, and then you can also you can reorient the sensor for proper orientation and operation. You always want to make sure your AlienRider logo is facing up. So if you need to rotate it 180 degrees, just loosen these screws, rotate it, bolt it back in. There's also a target window for height of the sensor. They recommend that the radar unit be between 50 and 80 centimeters above road height. So actually on my F800 GS, I'm a few centimeters high, not many, maybe I think 4. And it works fine. There's no issue there. So I think that's a recommendation, but if you're compelled to put it a bit high, it's still going to perform. So I'm going to talk about kind of the indications you get. I don't have a powered unit right now, but if you were to have blind spot alerts, I'm going to talk about those in a minute. They're going to populate here as these bars on the sides of the screen corresponding to the where the target is, and they'll be yellow or red. So you get a yellow warning or a red alert. Same on this side if a target is over here on this side of the motorcycle. You'll get the same thing for the rear field of view. It'll come up at the bottom again as a yellow bar or red bar, whether it's a warning or alert. And I'll hook this up and try to include some video along with this tutorial or overview on the AlienRider LiDAR. So they just sent me a document that goes into a lot of detail on the LiDAR system operation. So there's a couple of points that I want to make. One is, you have the sensor technology. What the LiDAR sensor can see electrically or with light, and the signal it can generate. Same thing with a camera. It's going to provide an image, and then you have to process that, right? So there's, the sensors are only going to perform as well as the software that processes the data and then generates the indications on the UI. So I mention that because I want to highlight that Shenzhen ATS, which is the company that makes AlienRider M2 Pro, has a long history with delivering LiDAR sensors in the automotive space. They've been making LiDAR for cars, for Chinese manufacturers for many years. They supply to almost all the manufacturers over there, with the exception of BYD, because they have their own LiDAR technology, their own LiDAR manufacturing. So this isn't just someone, a newcomer coming into the industry, buying some 77 gigahertz sensors from a supplier and doing the minimal amount to get this thing integrated into the unit. They do deliver LiDAR in a motorcycle riding system because that's their expertise. And Ken, the owner of the company, is a longtime rider, so I think he recognized that as a kind of a personal challenge. Like, how do we bring LiDAR to the motorcycle world? And he did it, and they have a lot of experience with this technology. Okay, so AlienRider sent me this document that has a lot of information on the performance of the LiDAR safety system on the M2 Pro. So I'm going to use this as kind of a guide. Hopefully it doesn't become too boring, but it's a lot of information. I've got it a couple of days. I've read through it and digested it, but I wanted to go ahead and get this out to you guys. So we talked about the basic functionality, the idea of having alerts and warnings for blind spot on each side and rear collision. There's also a lot of configuration settings that I've covered in the configuration video, where you can enable and disable features. You can set the speed for when they become active, or certain aspects of the system become active. So, and also the M2 Pro has the ability to integrate external speakers on the bike, and then you can get audible alerts. It also has a camera switching feature on warnings, which will switch the display from whatever screen you're on. If you're in CarPlay doing some navigation, it can be configured to where it'll automatically switch to rear view mirror mode, and provide you video of what's going on behind your bike on a warning. So an interesting feature that wasn't covered in the initial documentation is that you can temporarily, or you can disable that with the 3-button controller. If we use the top button, which is the cycle button, or I think they call it a shift button. If you're getting alerts, let's say, because this annoyed me actually when I was driving in traffic, low speed, and I was navigating, and then it would take me away from navigation and throw video up there. So that's a quick, easy way to disable the rear camera switching, and it would also disable an audio alert. But I don't run external speakers on my bike. But if you did, this would disable that also, and you'll get notification on the screen when you toggle that. So that's a cool little feature. What else we got here? They go through configuration settings, which I covered in the config. It's all fairly straightforward. We're going to kind of talk about how the bike, or how the sensing performs when the bike has lean. If you have errors, if you have bikes that are in your blind spot and they're registering as a rear target, there's error adjustments. Let's see what they call that. Error calibration function, where you can slightly adjust the degree of the field of view of the sensor and induce an offset to get that aligned. So the mount comes with a lot of adjustment front to back, but this position is going to be fixed. Now there is an option to have a fully adjustable sensor with a ball joint here, but that's an option, and that's really for unique installation circumstances. For your average bike, this mount is going to work fine, and just make sure you get this bracket square and that you're able to tilt the sensor 90 degrees to the road, and you're going to be good. But if you do have a little bit of misadjustment there, you can compensate for that through the settings. So I'm not going to go through the settings in great detail. I really want to kind of talk about the functionality of the system and the algorithm. So one thing to understand about LiDAR is it understands your motorcycle speed, and then it can understand the speed of targets that it's tracking. So it can calculate relative speed, right? So, and it'll know if a target is approaching quickly or if a target is slowly approaching. And it has, intelligence in the software to make decisions or provide alerts and warnings differently based on those circumstances. So that's kind of some of the stuff that I'm going to talk about. One little highlight here is they wanted to note that they've done about 10,000 kilometers of testing on various roads, various riding conditions, highways, city streets, night riding, etc. Let's see what they say here. Okay, just some data points. False warning rates. So their false warning rate, they're claiming a number of less than 3% of target detection will be false warnings, and their misdetection rate is lower than 1%. So that's a car getting in, or an object getting in that field of view that should be detected but is not. False warning would be something like I've seen them once or twice where I was in a far left-hand lane and there was a big barrier and it indicated as a target. So those are the numbers there. I'm going to make some comparisons or provide you with information that I've gotten from the factory, and this is their information and how they contrast the performance of their system to camera-based systems. So they just make a statement that say camera-based blind spot warning systems have a much higher false warning rate. I don't have any first-hand experience with that. I don't run any camera-based systems, but that's what the factory is saying. Now they have another category of what we call static vehicle false warnings. So that's going to be where you're traveling down the road and you have a parked car next to you and you pass a parked car, and whether that provides an indication or an alert or warning for blind spot detection. And I have seen that. I have not seen any false warnings on static vehicles. The system is very, very good at understanding what's moving on the road. Let's see. Warning distance. So the range of this LiDAR sensor is going to be 55 meters. And that's even with high-speed driving. It says camera-based systems typically use wide-angle cameras, and that their distance operates in the range of 10 to 20 meters. And once you exceed 70 kilometers per hour, that the system loses effectiveness. So I'm not an expert on these things. I'm just trying to provide you the information from the factory, and these guys definitely are. So next topic is advanced warning distance. So they can provide warnings 30 to 50 meters in advance when the speed differential between a rear target and the motorcycle is between 10 to 30 kilometers per hour, which is going to give you 5 to 8 seconds of response time to deal with that jeopardy, with that condition. They're saying that camera-based systems, because they have a shorter field of view, that you're going to be limited to about 30 kilometers per hour to accommodate that same reaction time, if that makes sense. So the system, just because it's only seeing a smaller amount of road space, by the time it detects it, you're going to lose the ability to react to it, or it's not going to see things soon enough to allow you to have that adequate reaction time. Hopefully that makes sense. It talks about what they call humanized warnings for blind spot detection. And basically this is the system being able to adapt to congested traffic at lower speed in, say, urban driving. And then also, so in that condition, it's going to recognize that. It's going to see lots of targets. So it's going to tighten up its alert and warning bandwidth because it knows you're in a low speed environment with high density of targets or traffic around you. And then conversely, if you get out on the highway and you have fewer targets and it understands you're operating at a higher speed, it's going to open up that bandwidth and start processing targets over a greater distance to enhance that reaction time and give you more resolution on data over a wider time period, if you will, based on your speed. So that's pretty interesting and pretty compelling features. Let's see. Overtakes. Okay, so here in the Philippines, bikes are always going faster than cars. It's just the way it is. It's the nature of traffic and getting through traffic. I can confirm this firsthand. I pass cars all the time, at high speed, medium speed, and the system understands when I'm performing an overtake, and it does not alert on those. Now, occasionally I'll do a pass where I'm at a similar speed of a vehicle, and I'll complete the overtake, but I'm still only maybe I complete the overtake where I'm slightly faster than them, and then due to traffic conditions I have to end up matching or going slightly slower than them as a target, and then the LiDAR will re-engage and it'll pick them up as a target and start tracking them and generating alerts and warnings. So I've seen that firsthand. I really want to get you guys some video on this stuff, but I just got my Ace Pro. I'm going to helmet mount that, and I'm going to get that done. I'm going to shoot that at night so we get best visibility, and that's coming. Sorry I haven't been able to generate that yet. Next, we want to talk about environmental conditions. So a LiDAR, radar-based blind spot detection, it's going to operate in snow, fog, day, night. It doesn't care about lighting conditions, whether you have strong sunlight or dusk lighting conditions. That's not going to impact the performance of it being able to track targets. Camera-based systems are going to suffer from that. Let's see what it says exactly. Especially, it talks about headlights, providing light directly to the cameras, or low visibility, foggy weather, rain, snow, are all going to degrade the performance of a camera-based system for target monitoring and detection. Let's see, what else can we go through here? Okay, we're going to talk a little bit about the function of LiDAR when you would induce a lean in the motorcycle. So this is going to be when you're executing, going around a curve, whatever's causing you to lean the motorcycle in a road condition with traffic. It will change the aspect ratio or the coverage of the LiDAR sensor. But let's see what it says here specifically. It'll experience deviations, but the radar system has a wide enough detection range that it will not miss a target. As a target vehicle approaches, it will naturally re-identify the position and provide accurate warnings. If your motorcycle sways or tilts a certain angle, the waves will also deviate and target directly. So what I think my interpretation of this is you may start seeing the target shift slightly, and it may reclassify where those targets are. So in a maybe in an extreme lean, it'll sense a rear target. Then obviously the position relative to the motorcycle. These targets can be misclassified into, say, a blind spot position where really it's a rear position or it's in the same lane as you. I mean, technically, the sensor is identifying it appropriately, but because of the curve of a road and the lean of the bike, it is possible that you may have momentary misclassifications, and then as you recover, the LiDAR system will reclassify those targets and bin them or place them or match them to the appropriate alert. So I think it's pretty cool that they address that and let you know that that's a reality of physics, and the sensor moving relative to the roadway and you being in a curve in the road. Let's see. We're going to talk about innovations real quick, and this is where they're going to talk about basically features, enhancements of LiDAR over vision. So if you do a roadside stop and you do get warnings from passing vehicles, you can actually tap the screen and it'll do a 5-second grace period where it suspends alerts. What else? Okay, so now let's talk about the urban congested traffic sensing environment. They give some detail on that, and I thought it's worth pointing out. So this is where the relative speed recognition of the system comes into play, because it's going to provide indication differently based on your speed and the speed of relative targets. So it says when you're in congested roads and you have traffic at speeds of 0 to 35 kilometers, to avoid unnecessary inconvenience of excessive warnings, level 1 warning, which will be a let's see, I have to get some clarification. I think they're trying to say the alert or the yellow is going to be at a 10 meter operational distance, and then level 2 is going to be at 6 meters. So then when you increase speed in the user's motorcycle, when you're driving 35 to 65 kilometers per hour, then those monitoring bands or distances are going to increase to 20 meters for initial warning or alert, and then level 2 warning is going to become 8 meters operational field of view for tracking targets. And then lastly, if you exceed 65 kilometers per hour, then that level 1 alert, or they're calling it a warning, moves out to 40 meters of visibility, and then the level 2 warning, red warning, triggers at 10 meters. So pretty neat stuff. It's cool to learn a lot about this LiDAR system. Let's see. Filtering of invalid targets, the last thing on their enhancements or innovations. When a motorcycle surpasses a target vehicle and the speed difference is less than 5 kilometers per hour, the BSD issues a warning. When the speed difference exceeds 5 kilometers per hour, the warning is ignored. So that kind of jives with what I was mentioning earlier, my observation. So when you're overtaking and your speed differential is greater than 5 kilometers per hour, it's going to assume you're aware of the target because it's a target ahead of you that you're overtaking. But if you slow down that overtake and you're overtaking less than 5 kilometers per hour, it's going to provide alerts and warnings so that you're aware of that target, just because you may be you have a lower relative speed, and you can be managing traffic, and it wants to provide that visibility for you to be aware, even in an overtake circumstance. So they put a lot of thought and development and a lot of robustness is built into this LiDAR system. And this is a key and a hugely significant technology difference between the AlienRider M2 Pro and other premium writing systems on the market. I got to tell you that we've delivered this to a number of writers here in the Philippines, and without a doubt, 100% of the feedback has been that they love the LiDAR system. That to the extent that they're talking, they're like, I can rely on this thing. I don't know if I want to go there. I still turn my head. I throw my, I put eyes on my blind spots when I'm making a lane change, or still being vigilant with vision on overtakes and driving. But that's the feedback I'm getting. I don't know if I could go there yet, but that's how good the system is. So there you have it. That's kind of a deep dive on the LiDAR technology in the AlienRider M2 Pro. If you stuck with me this far and you've absorbed all these details, and I know maybe the way I explained it can be kind of confusing, I'm happy to provide clarification based on the document. We'll get the document fully translated and then up on the Next Gen Writer support page so you guys can read through it. But if you have some questions, drop some comments. But this is a very, very capable safety system, and it performs very, very well. So look forward to some video on this. I want to get that out for you guys. Anyway, thanks for watching.